Earth, a planet which gave us life, but will it last forever? Everyone wonders how our life will end on this beautiful planet. Will we turn into zombies and eat our brains? Or were the Mayans right about the end of the world on December 21st, 2012? Well, maybe. But is this really possible? What if something else happens? What if death came from the stars? Seems very romantic. But it's no fun. Did you ever think of that? Every second our sun is getting older. What will happen when it finally dies and destroys everything it created?
The sun will probably shine down on our civilizations for as long as they exist. If we survive for another billion years, the sun will still be there. But just as the sun was once born, it will one day die. And when it does so, it will take the Earth with it. In about 5 billion years' time, the sun will run out of hydrogen. When it does, it will become a red giant. Deprived of fuel, the core will shrink, generating so much heat that the outer layers will balloon into the solar system. The inner planets will be swept up. It may even swallow the Earth. Whether it is engulfed or not, the Earth is doomed. The sun, burning 2,000 times hotter than it does now, will melt and seal the outer layers of the planet. Then suddenly, the sun will stop burning. As the remains of the solar system is plunged into darkness, the sun's core will collapse, and with its last gasp, it will blow its remaining shroud of gas into space. It will be forever night. The story of the sun and the Earth will have ended, and a small part of the outer arm of the Milky Way will be a little bit darker. But around it, in the rest of the universe, the same story will be being told by a billion other small, insignificant stars twinkling in the vastness of space.
Yes, the sun is trying to kill you. Nothing personal. It's trying to kill me too. The sun is currently heating up due to the fusion of hydrogen into helium at its core. As this process goes on, and the hydrogen at core runs out, one day when we look up into the sky, the sun will occupy about 1/3 of our sky. In fact, the sun will have expanded to 100 to 150 times its current size. Why is this the case?
The main sequence of stars like Sun, about half solar mass up to 10 solar mass, at the end of their life, when they run out of hydrogen at the center, they become red giant. But how this process happens, when you don't have any source of energy at the core to produce energy and to produce heat to keep the balance between the gravitational force and the heat pressure from the inside, then the entire star collapses into the core. But it happens very quickly. When it happens, you can start nuclear reaction again and converting hydrogen to helium around a shell around the core, because the core itself doesn't have hydrogen anymore. And that process is very quick and it produces lots of energy. That makes the star to pop and become much larger and releases lots of energy in a very short time. When the stars become larger, we call it a red giant. Why? Because now it has a larger surface, it becomes brighter, but because the energy is divided into a larger surface, it's colder. It's mostly like an orange color star, but well, we call it red giant, and that's why it becomes red and it becomes much larger.
Reaching out to swallow us. But this, fortunately, is not going to be the case. As the sun expands and its mass stays constant, the gravity will decrease. So for a particle near the surface of the sun, it would feel like someone turned off gravity and turned on a superpower fan from below. The sun will lose its hold on Earth. Through calculation, scientists have agreed that Earth will evade this fiery law. This, however, is not the end of the line.
We don't need to worry about that now because the sun is at the middle of its life. It's 5 billion years old. So it still has 5 more billion years to hydrogen at the core to just remain a main sequence star. But what happens when the sun becomes red giant? It will be so huge. It will almost swallow the Mercury. It may also swallow the Venus. It will be very, very huge. So at that time, it depends on where is the Earth at that moment. Maybe the Earth is still at the same orbit. It's not going very closer to the sun or very farther from the sun. And so the surface becomes very hot. It would be probably something like what we have now in the Venus. It would be very hot, so it cannot contain the liquid water on the surface anymore. So first of all, it's going to be very hot, very dry. All the water liquid goes to the atmosphere and vapor, and after a while, also that water liquid also in the atmosphere also will be vanish, and actually the Earth is going to lose its atmosphere as well. So Mercury and Venus are almost swallowed. Earth is burned by a hot, very huge star. But this mass is expanding. It's going to create planetary nebula after that. Because the sun is losing most of its mass and only the white dwarf is becoming at the center, then it doesn't have enough mass to keep other planets. So what happens to the rest of the solar system is maybe the Mars, Saturn, Jupiter, and all other outer planets probably cannot be kept and bound into the solar system anymore. Most of them become to have a larger orbit and probably leave the solar system after a while.
65 million years ago, the dinosaurs had a bad day, and right now we are still on a target in space. Getting hit means absolute doom. Firstly, plunging through the air, the asteroid would cause a huge shockwave, superheating the atmosphere for miles around it. It would have set everything underneath it aflame before it even hit. Then the asteroid contacts with Earth, and another giant shockwave slamming into the Earth's crust, all those millions of megatons of energy exploding outward, sending molten rock and vaporized seawater upward and outward. Following the ground shock would be an air shock, a sonic boom, deafening any survivors from the previous shock. Furthermore, when the asteroid punched a hole in the Earth right through the crust, the energy of the impact would send molten rock hurtling into the air like intercontinental missiles, setting the whole world on fire. A certain asteroid is coming. Can we do anything to save us? Yes. There is an interesting mission named B612 Foundation that works on creative ways to dissolve the danger. The best way is to use a gravity tractor, a spacecraft that flies near the asteroid for years. The Earth really is small in space, so it does not take much for the gravity between the two to alter the orbit to miss the Earth in the future. Here's a subject that's less geologically catastrophic: Earth's magnetic field. Earth has a magnetic field that is immensely important to life. It not only gives us our sense of direction with the use of compasses, but it also protects us from the cosmic radiations such as solar winds from our sun and exploding stars. It is generated by electric current flowing in the outer core deep inside the Earth. The magnetic field constantly is in motion. This is something that scientists have always known. Every 250,000 years, the field has reversed. The South Pole was once the North Pole. According to evidence, the last reversal was 780,000 years ago, which means we are long due for one. In the past century, our magnetic field has decreased 5%, which supports the possibility. The geographic poles and the magnetic poles are far away enough that a distinction between the two can be made. In fact, the magnetic axis is tilted 11.3 degrees away from the Earth's axis of rotation. Gamma ray bursts, the universe's most extravagant explosion, is something that still captivates astronomers today. Discovered in a recent 1963 via U.S. military satellite, GRBs have been shown to be evenly distributed across the sky of space. They are 100 times more powerful than a typical supernova and are 10 quadrillion times more energetic than the sun. What causes these energetic phenomena? They are caused by collisions of black holes and neutron stars, or a combination of the two. They can also occur when massive stars run out of nuclear fuel. As a result, high-energy gamma radiation is released into space. Gamma ray bursts last anywhere from a few milliseconds to minutes. They are roughly detected once every few days.
But suppose a gamma ray burst happened nearby, in our own galaxy. I don't want to be around for that day.
Because gamma-ray bursts travel at the speed of light, towns around the globe would have no warning that a cosmic disaster was about to unfold.
If a gamma ray burst bursts, it'll be the brightest thing in the night or day sky. Won't be one sun in the sky, you'll see two suns. You'll know something bad is happening.
Although the closest star to the Earth that could explode is 8,000 light-years away, even at that distance, a burst headed toward Earth would be catastrophic.
What it would do is it would boil off, essentially, the whole top of the Earth's atmosphere. And the consequences of that are very drastic.
First thing they'll do is take out our ozone layer. Completely take out all the ozone. Once you do that, by the way, the ozone is our defenses against high-energy radiation. So if that shield gets knocked out, we are bare.
Without the protection of the ozone layer, everyone around you, even those hiding in their basements, would begin to get what looked like a bad sunburn from the gamma radiation as it penetrated into the Earth's crust.
This is light, has enough energy to completely decompose the molecules that are the stuff of life.
Temperatures would rise dramatically. People outside would be burnt by the ultraviolet radiation. Without an ozone layer, anything with eyes would eventually be blinded. We're talking about the end of all life as we know it.
Within days, the radiation would begin to impact every living thing on a molecular level, stopping all cells from reproducing. Our fingernails and hair would stop growing, and worse, the cells in our intestines would stop regenerating, leaving us unable to absorb food or water.
Most of the living things on the planet, plants and animals alike, would not survive that kind of radiation.
After 1 month, almost all life would be gone from the face of the Earth. However, the remnants of our civilization, the buildings, cars, street lamps, would remain intact.
If any life survives a nearby explosion of a gamma ray burst, it would be the microbes that live deep under Earth's surface. There's some hope that life on Earth would continue, but bacteria will rule the world.
Considering all things that can happen, they seem to be bad, right? There is one thing that is worse, the end of the universe. Not only would Earth be destroyed, but everything beyond it. Time and space would cease to exist. Before Edwin Hubble discovered that the universe was expanding, everyone thought that the universe was static and unchanging. No one thought that the universe was going somewhere, almost running towards its death. But thanks to Albert Einstein, a German scientist, we understand our universe a little better and can predict its death. In 1905, Einstein presented the theory of relativity, which became a pillar of modern physics. From the theory emerged the three major models of the universe that also predicted its ultimate fate. As you can imagine, they turned out to be quite shocking. Even their creator didn't believe the results could be correct. They showed that the universe was much more than static, it was in motion. So, Einstein came up with an idea of a universal constant that makes the universe static and stops gravity from crunching the universe. But when the expansion of the universe was announced on the 1st of January 1925, Einstein called the universal constant his biggest blunder. Wait a second. Isn't that supposed to be dark energy? Was Einstein right to some extent? It seems he was ahead of his time, as always. So let's get to the point, the end of the universe. Actually, everything depends on the amount of dark energy our universe has. How ironic. If our universe has too little dark energy, it will finally stop expanding and start shrinking. Time and space would fall into one point, an infinitely small and dense object called a dimensionless singularity. Physicists like to call this phenomenon the Big Crunch, or the anti-Big Bang. Weirdly, the Big Crunch ends with what the Big Bang starts with, a singularity. Therefore, we can speculate that our universe goes through a number of Big Bangs and Big Crunches. Good news for the universe, bad news for us. We'll never survive this. What if the universe has too much dark energy? An open universe, which not only expands but accelerates. In this case, there are two possible outcomes, and surprisingly, they are very different from each other. One of the possible ends is the Big Freeze, which, of course, occurs when the universe expands so much that the objects are distributed evenly. The temperature reaches 0 Kelvin, which means that particles won't have any energy and won't be able to carry any sort of information, which is crucial to society. Another possibility would be the Big Rip, which is caused by an increase of volume of dark energy and increase in the constant, which will result with matter being literally torn apart, and the end result yet again will be severe. Poor Earth will even stand a chance. These are the ultimate fates of our humans. There's nothing. We can't fight. There isn't any hope for survival. Well, just remember, this only happens in theory. But death is a natural process, and there is little we can do to stop it, especially when the forces of nature go against us with so much power and determination. Nothing lasts forever, and the sooner we understand it, the better.